Somewhere out there, beyond the last planet you were ever taught about in school, something is waiting. It has no name on any official star chart. No photograph hangs on any wall. No child has ever drawn it in a classroom. And yet, it is almost certainly real. A world, roughly 4 times more massive than the Earth beneath your feet right now. Locked in a freezing, pitch-black twilight at the very outermost edge of our sun's gravitational grip. A single year on this planet lasts up to 15,000 human years. We have never seen it. Not one telescope on Earth or in orbit has ever captured so much as a single photon of its light. And yet, the world's top astrophysicists are hunting this phantom with an obsession that borders on madness. This is the enigma of Planet 9. An icy, rocky titan orbiting up to 500 times farther from the Sun than Earth. A world so remote that sunlight reaching it is no brighter than a distant star on a clear night here at home. It sits tilted at a bizarre angle, mocking the flat, elegant disk that every other planet obeys. It traces an orbit so extreme, so eccentric, that it swings from the distant fringes of the solar system all the way back toward the inner realms, and then vanishes into the dark again for thousands of years. But here's the question that should keep you up at night. How do you map a world that absolutely refuses to be seen? The answer is deceptively simple, and it is as old as science itself. You do not need to see the monster. You just need to look very carefully at the things it is tearing apart. To understand how scientists find invisible worlds, we have to travel back 2.5 centuries. It is 1781. A British astronomer named William Herschel is scanning the sky for comets when he stumbles across something unexpected. A faint, disc-shaped smudge that moves. Not a star, not a comet, a new planet, Uranus, the 7th world, discovered entirely by accident. The scientific community is electrified. Suddenly, the solar system is bigger than anyone imagined. Astronomers begin meticulously tracking Uranus across the sky, year after year, charting its path with obsessive precision. And then, something goes wrong. Uranus is not keeping time. It would randomly accelerate, then inexplicably slow down, deviating ever so slightly from the elegant laws of physics that govern everything else. In astronomy, this is called a perturbation, a cosmic tug-of-war. Something was out there, pulling on Uranus. Something massive. Something unseen. In 1846, 2 mathematicians on opposite sides of Europe, Urbain Le Verrier in France and John Couch Adams in England, did something that had never been done before. Working entirely from equations and nothing else. No telescope, no observation, just pure mathematics. They each independently calculated exactly where an undiscovered planet would have to be to produce that gravitational tug. They sent their coordinates to an observatory in Berlin. In less than 1 hour, astronomers aimed their telescope at the predicted spot. And there it was, Neptune, discovered by math before it was ever seen by human eyes. Emboldened by this triumph, astronomers tried the same trick again. A perceived wobble in Neptune's orbit led them on a decades-long hunt for yet another hidden world, a so-called Planet X. In 1930, they found Pluto. Champagne was poured. Headlines were printed. A schoolchild in Illinois even named it. There was just one problem. Pluto was a cosmic red herring. It was laughably too small, about 1/6 the mass of our moon, to produce any meaningful gravitational pull on a gas giant. Decades later, when Voyager 2 flew past Neptune and scientists refined their measurements, the wobble vanished entirely. It had been a calculation error all along. The hunt went cold, for 70 years. Until a frozen graveyard at the edge of the solar system changed everything. Over the last 30 years, our telescopes grew dramatically more powerful. and in the frozen darkness beyond Neptune, we discovered something extraordinary: the Kuiper Belt. A vast, chaotic scrapyard of billions of icy objects, ancient planetary building blocks left over from the formation of the solar system. Fragments ranging from pebble-sized to hundreds of kilometers across, drifting in slow, frozen orbits at the very outer edge of the sun's reach. Scientists catalog them by the thousands. And inside all that chaos, the ghost reappeared. In 2016, two Caltech astronomers, Mike Brown and Konstantin Batygin, noticed something that made them stop cold. The most distant objects in the Kuiper Belt were not drifting randomly. 6 of the farthest, most isolated objects that by all rights should be scattered in every direction, were all swept to the same side of the solar system. Their orbits tilted in nearly identical directions, clustered together like iron filings pulled by a magnet hidden under a table. The statistical odds of this happening purely by chance? 0.007%. Something was out there, hurting them. When Brown and Batygin ran a computer simulation incorporating a planet roughly 4 to 5 times the mass of Earth, on a highly elongated orbit roughly 400 to 800 times farther from the Sun than Earth, the chaos snapped into perfect alignment. Every anomalous orbit clicked into place like tumblers in a lock. But this raised a deeper question. Where did Planet 9 come from? The outer solar system is far too thin, too cold, too empty for a planet to form there on its own. Scientists have 2 leading theories. Theory 1. It is a rogue, a planetary core stolen from a passing star system billions of years ago, captured by our sun's gravity in the chaotic early days of the solar system. Theory 2. It formed right here in the inner solar system, a would-be 5th gas giant whose orbit was violently disrupted by the gravitational bulldozing of Jupiter or Saturn, flung outward to the dark fringe and abandoned there, slowly tracing its lonely ellipse ever since. Either way, something is out there, and the evidence is about to get much harder to ignore. Now, here is where the story takes a genuinely shocking turn. For years, Planet 9 was an elegant theory. Compelling mathematics, strong statistical evidence, but not a single direct detection. That began to change in 2025. Independent teams of astronomers from multiple institutions did something surprisingly simple. They went back. They pulled out decades-old, largely forgotten infrared data from 2 satellite missions: NASA's IRAS telescope from the 1980s and Japan's Akari telescope from the early 2000s. Data that had been sitting in archives, largely unexamined, for as long as 40 years. Then, they ran that old data through modern artificial intelligence algorithms. Algorithms trained to detect the faint infrared signature of a cold, dark world drifting in deep space. The results were extraordinary. 13 distinct candidates emerged from the data. 13 faint, cold objects glowing at temperatures hovering around -220 degrees Celsius, barely above absolute zero, in the deep infrared spectrum, at the exact distances and positions consistent with Planet 9's predicted orbit. Now, this is not a confirmed detection. Scientists are appropriately cautious. Some of these signals could be instrument artifacts or distant background galaxies. Follow-up observations are urgently underway. But 13 candidates? All in the right place? All at the right temperature? For the first time in this search, the theory is producing real, physical candidates, not just mathematics. But wait, it gets stranger. In late 2025, researchers from Princeton University threw a massive wrench into the gears. Their simulations showed that Planet 9, alone, cannot fully account for every orbital anomaly in the outer solar system. The math demands more. Specifically, it demands another hidden body, closer to us, that nobody has been looking for. They called it Planet Y, a world somewhere between the size of Mercury and Earth, hiding in a region of the sky that has received far less scrutiny than the distant Kuiper Belt. something that has potentially been lurking within our own extended solar neighborhood for billions of years without anyone suspecting its existence. We went from searching for one ghost to hunting an entire family of them. The solar system, the one you thought you knew, just got considerably more complicated. Now, in the interest of intellectual honesty, we have to address the skeptics, because some of them have very compelling points. First, observational bias. Humans are pattern-seeking creatures. We find what we are looking for. Some astronomers argue that the clustering of Kuiper Belt objects we have detected so far represents a biased sample. We simply haven't surveyed enough of the sky to rule out a random distribution. Second, and this one is genuinely wild, a group of researchers from Harvard proposed that what we are interpreting as Planet 9's gravitational signature might actually be caused by a primordial black hole, a microscopic singularity smaller than a grapefruit, left over from the first seconds after the Big Bang, drifting invisibly through the outer solar system, pulling on everything around it with the gravity of a planet while emitting almost nothing. And third, modified gravity. A small but serious community of physicists argue that Isaac Newton's laws of gravitation, and even Einstein's refinements, might behave subtly differently at the vast scales of the outer solar system. What we are calling a phantom planet might simply be an effect of gravity we do not yet fully understand. These are not fringe ideas. They are legitimate scientific hypotheses, worth testing with the same rigor we apply to Planet 9 itself. But the age of educated guessing is officially over. The Vera Rubin Observatory in the Atacama Desert of Chile has entered its full operational era, and it is unlike anything ever built. Its camera carries 3.2 gigapixels, the most powerful digital imaging sensor ever constructed. Every 3 nights, it photographs the entire visible southern sky. Every 3 nights. A continuous, all-sky time-lapse running for an entire decade. In 10 years, it will produce more astronomical data than all previous sky surveys in human history combined. If Planet 9 or Planet Y are out there, reflecting even a fraction of a single % of the sun's light, their motion against the background stars will betray them in the accumulated image stack. There will be nowhere left to hide. We will not be searching, we will be screening. Every object in the outer solar system, cataloged, tracked, and cross-referenced, automatically, in real time. The universe is under no obligation to make sense to us. For billions of years, Planet 9, if it exists, has been tracing its vast, solitary orbit at the edge of everything we know, indifferent to our curiosity, indifferent to our instruments, indifferent to our equations. But science is patient, and the Rubin Observatory is relentless. Within the next 2 to 3 years, we will know. Either we rewrite the maps of our solar system forever, adding a new world to the family of planets, a world more massive than Earth, more ancient than any civilization, or we prove, finally and definitively, that the dark edge of our cosmic neighborhood is emptier than we ever imagined. The cosmic phantom's time is running out, and ours is just beginning.